SS2 physics students. Remember where we started last time? We discussed the difference of light at curved surfaces, and we are able to indicate the two types of curved surfaces we have parabolic and spherical. It's called a parabolic curved surface. The use of it, remember, is used in car headlamp or searchlight. That's the reason for that. Also, it's called the parabolic curved surfaces. There we have concave and convex mirrors. We're able to discuss how to indicate or how to identify two of them, one curve inwardly, one curve outwardly. Also, we're able to discuss image formed by the two curved mirrors, the properties of image, that of concave mirror, the image property varies based on object position. In case of convex, it has one particular type of image no matter the object position. Based on that, the convex mirror is used for driving mirror. Then the concave was able to produce magnified image. Based on that, it is used as a shaving mirror. In continuing with that topic, I gave you what they call mirror formula. I can use that formula to solve problems and connected with that curved position of light and curved surfaces. Today I'm going to solve two problems on that before I'll switch to refraction of light. The question is a concave mirror of focal length is 20 cm is used to produce image twice the size of the object. How far is object from the mirror? Produce image, you need to produce an image twice the size of an object. Image twice the size of an object. When you are given this type of problem, you move straight to your mirror formula. Mirror formula says 1 over rho plus 1 over v equal to 1 over f. Where rho, as I told you, is object distance from the mirror, v is image distance from the mirror, and f is focal length. In this case, you know the focal length, you don't know rho, you don't know v. Then, I have to find v. How far? How far is object? How far? How far? How far is the object? How far is object from the mirror? From wasting somebody's time. How far from the mirror? Which means you have to find your object distance from the mirror. Then you don't know you don't know v. Now, but you know m. Remember I gave you that m is equal to v over rho or equal to I h over O h. Where v is, I told you, image distance from the mirror, U is object distance from the mirror, IH image height, OH object height. And I was told that this is twice, M is twice magnification. 2U is equal to V. Image is twice the size of the object. Twice the size of the object, which means that V is 2U. So if I go back to the equation, I have 1 over U plus, I won't write 1 over V again, I'll say 1 over 2U is equal to 1 over F. Because I've replaced V by 2U based on the equation asked. Here is 1 over U plus 1 over 2U equal to 1 over 20. LCM is U. U into U is 1. 1 times 1 is 1. 2U, LCM is 2U, please. U into 2U is 2. 2U into 2U is 1. So to give us 3 over 2U. So 3 over 2U is equal to 1 over 20. Cross multiplication, 2U is equal to 60. U is equal to 30. So it is 30 cm from the mirror. 30 cm, how far is object from the mirror? Is 30 cm from the mirror. Okay, another question. An object is 20 cm. 20 cm from the mirror, and you to produce 20 cm from a concave mirror, and you to produce an image. If the focal length of the mirror is 10, F is 10. Find 1. Position, size, and nature of the image form. Now, three things to do here. 3 things. Before I solve this problem, I will remind you of the rules. Real. In solving this problem, real is positive, and the visual is negative. What does that mean? Now, when you solve a problem and you obtain a positive number, 1, 2, 3, 4, 5, it is that indicates that the image form is real image. So when you solve it and get a negative number, minus 1, minus 2, minus 3, indicates that that image is visual image in case of nature of the image. Now let's look at the question now. I go to my formula. Remember that we use concave mirror here. When you use concave mirror, F is plus. You have plus F. If you use convex, F is minus. So when you have to know the mirror you are using. So here I'm using concave mirror. So I now say 1 over U plus 1 over V is equal to 1 over F. What is 1 over U? U is 1 over 20 plus 1 over V is unknown. Equal to 1 over 10 focal length. And 1 over V is equal to 1 over 10 minus 1 over 20. LCM is 20. 10 into 20 is 1. This is 1 or 2. 20 into 20 is 1. To give us 1 over 20. 1 over V is equal to 1 over 20. Implies that V is equal to
20 cm. Now, let us start asking the question. Position. Image is 20 cm from the mirror. Position. Image is 20 cm from the mirror. That was the position. Then, size. Size. I go to magnification. M is equal to V. M is equal to V over U. From here, what is V now? V is 20. What is U? U is 20. We'll give you 1. So the image is the same size. The same size as the object. That's the under size. Then nature. Because you produce plus 20, image is rare. Image, remember, rare is positive. Where is it? Rare is positive. So the image is rare. Let us have another question now. The last question I will handle. Then the same procedure. Let us now talk about U is equal to 20 cm. Find F is equal to 10 cm. Find V. Here we are using convex mirror. The same procedure. 1 over U plus 1 over V equal to 1 over F minus equal to minus 1 over F. You know why minus here? Remember, convex has a visual focal length. We call that 1. So from here, 1 over 20 is equal to now plus 1 over V equal to minus 1 over 10. 1 over V equal to minus 1 over 10 minus 1 over 20. LCM is 20, equal to give you minus 3 over 20. 1 over V is equal to minus 3 over 20, imply that V is equal to minus 20 over 3 equal to divide 6.67 cm minus 1. Yes. Now, then position. Image is, don't say minus 6.67, it is 6.67 cm from the mirror. Minus has a language of its own, so don't indicate minus here. It gives OBJ. Then size. The same thing. V over U is equal to 6.67 over what is U? U is 20. U is 20. U is 20. You divide it 0.334. 0.334. So the image is diminished. It diminished. Remember, I told you that convex mirror produces one diminished image, erect image, visual image. That's good. Then under the nature again, nature image is visual because it is minus answer. V is minus 6.67. So you have seen that what you explain about product of image formed by visual by convex imaging has been demonstrated. So with this, I have finished comfortable with the reflection of light on plane surfaces and curved surfaces. So I go to what is called refraction of light. Refraction of light. Refraction of light. What is refraction? And what causes refraction? What is refraction and what causes refraction of light? refraction of light. Have glass block, the house music. So I'm going to handle with the glass block. Refraction of light means change in the direction of light as it moves from one medium to another of different density. Change. Let me bring him on around. If somebody is pursuing you and you are running by the other, your Bukhara is pursuing you. Why are you the Bukhara that when it meets you, you know you have gone. So you have to run. You are running and you meet a slippery ground. A ground that is slippery, water. Would you run with the same speed? Answer is no. If you run with the same speed, you are going to fall. So you are going to reduce your speed. So here, when light moves from one medium to another, the speed changes. That change in speed brings about change in direction. Therefore, refraction of light is caused. It's caused because of different in the speed of light in different media. Light travels with different speed in different media. Because that different speed, it brings about change in direction. You have to know what the refraction is and what causes it. If you ask the question, what causes refraction? Why does refraction occur? It means that light moves with different speed at different medium or different media. Effect of refraction. There are certain things you observe which is linked with the refraction. You may not know it, but you're going to know it now. Go and experiment all these things. Look at the pond. Direct. Look at the pond. You will see that the depth of the pond appears to be up. That's sometimes when you don't know how to swim. You see, look at the depth. It's not deep. I can swim. You enter there. That depth is above you. You will drown. So the depth of the pond appears to be shallower than the actual depth. So you have to know that. Number 2, get a glass cup. Pour water inside it. Get a stone, any object, either coin, stone, put it there. Look by the side of the glass. That stone appears to be very big than the actual size. If you look at it, almost very stone now. This small stone I put inside it appears to be very big. Another one, this one I have to do this one in the lab. Get a glass block. Like this. Make an ink dot on a paper. And cover that ink dot with a glass block. The ink dot appears to be inside the glass block. That ink dot appears to be inside the glass block. Then another one, get a stick, a straight line stick, a straight stick or rod. Pour water inside a glass cup again. Put a stick inside it. Put that stick inside it. Like this. Or look at this. That stick appears to be bent. It appears to be bent. These are effects of refraction. These can be explained based on refraction of light. It asks you which of the following phenomena can be explained based on light refraction. They will put one out of the many, no region. So no, I'm giving you up to 4 effects of refraction. Then I'll move to the laws of refraction. You know, we discussed laws of reflection, who were discussing reflection. Now I go to what we call laws of refraction. Laws of refraction. Now, have law 1, which says that is similar to that of reflection. Also, just slight difference. The first one said that the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. In reflection, we use the incident ray, the reflected ray. But here we say the incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. That is the first law. Second law, which is called Snell's law. Second law is called, call it law 2 or Snell's law. In our own language, Snell is the Angela, but this one is the human being. Snell's law. The law said that the ratio of sine, of angle, of refraction, of incidence to the sine of angle of refraction is a constant known as refractive index. Let me take it again. As I take it again, count number of there. If that number of there is not in your own answer, you score 0 there. It states that the ratio of face of sine of second of angle of third of incidence to the sine of fourth of fifth of to the sine of angle of refraction is a constant. Mathematically, we are saying sine I over sine R is mu. M means mu, refractive index, for a given pair of media, refractive index. So that is the second law. I will go to demonstrate that. Then, that's the two laws. And after that equation, what is, and this mu is constant, what is refractive index? What is refractive index? From here, refractive index is defined as the ratio of sine of angle of incidence to the sine of angle of what? Refraction. That's refractive index. Then let us draw a diagram to illustrate these things vividly. And so, you know, I say glass block. Glass block. This is glass block. This is our normal. This is our incident right now. But here is angle of incidence. What's incident? This is refracted light. Here is angle of refraction. Here is emergent light. This is angle of emergence. So you have to know these terms used in light refraction. AO, incident light. OB, refracted layer. OC, emergent ray. You have to know all these things. Then I move to what we call critical angle. Critical angle. Critical angle. What is critical angle? Critical angle. Before critical angle, you can, apart from angle, you can also get mu, refractive index, as real depth over apparent depth. Real depth over apparent depth. Or mu is V1 over V2. Here I is angle of incidence, our angle of refraction. Real depth, the actual depth of the point, apparent depth, the depth we want it appears to be. V1 is velocity of light in the first medium, medium 1, over velocity of light in second medium. These are what I use to do the calculation. As time comes, we will see how to use it. The critical angle. What is the critical angle? I will demonstrate it here and then define it. Before you talk about critical angle, you have three diagrams. A, B, C. Do I need three diagrams? Next lesson, I will start from there. Next lesson, I will start from there. So very important to know is critical angle and total internal reflection. And that should be the, after that, you do calculation, that should be the end of that topic before you go to triangular graph prism. So thank you. And you know, life is very simple. It's a sweet part of physics. Read it. Look at the topic, read it on your own, in your textbook. So when I'm demonstrating, you'll be following. Thank you. Stay safe, put all things necessary to avoid coronavirus, and then revise your notes, past questions, and read textbooks.